Hi guys, this is O-level chemistry, paper 12, November 2022, question 11. Boron trifluoride BF3 is a simple molecule. There are three covalent bonds in each BF3 molecule. Each of these bonds is made by sharing one electron from the boron atom and one electron from a fluoride atom. So basically, if there is a boron here and there are three bonds, so there are three fluorine atoms here. And it says that one electron is coming from boron and one electron is coming from fluorine. Now, fluorine belongs to group 7. So each fluorine will have six other electron in the outermost shell. So this should be the structure of boron trifluoride that is drawn here. Okay. Now, what is unusual about bonding in boron trifluoride? Okay. Let's see what is unusual. It is unusual for a non-metal such as fluorine to form covalent bonds. No, it forms a lot of covalent bonds. Even the fluorine-fluorine atom in F2 is held by a covalent bond. So obviously this option is wrong. Next. The boron atom in each molecule does not gain the electronic configuration of a noble gas. So as you can see, boron belongs to group 3 as seen in the periodic table, and it is forming three bonds here. So when it is forming three bonds, so total number of electrons present in its outermost shell is 6, whereas a noble gas has 8 electrons present in its outermost shell. So this option is correct. Next, the covalent bonds do not consist of shared pair of electrons. What else do they consist of? Option D, the fluorine atom in each molecule do not gain the electronic configuration of a noble gas. As you can clearly see, there are 7 crosses and 1 dot. So altogether 8 electrons, and the noble gas configuration is 8 electrons. So this option is also incorrect, making option B the correct option for this question. Question 12. Which equation is correct for the reaction between carbon dioxide and magnesium hydroxide? Let's just make the equation and see which option is correct. We have carbon dioxide, which is an acidic gas. We have magnesium hydroxide, which is basic in nature. So an acid-base reaction is taking place here. So carbon dioxide will react with magnesium hydroxide, forming magnesium carbonate, MgCO3. And this is the salt in this reaction. And the remaining part would be water. So we have two hydrogen and one oxygen remaining. So this is water. So this would be the equation for the reaction of CO2 with MgOH twice, which is the option A out of the four given options. So option A is the correct option for this question. Question 13. Which mass of oxygen gas combines exactly 16 grams of sulfur to form sulfur dioxide? So sulfur plus oxygen gives SO2. So the AR of sulfur is 32. The AR of oxygen is 16. And there are two oxygen atoms. So this is also 32. And the MR of SO2 would be 32 plus 32, 64. So in other words, the ratio of sulfur is to oxygen is 1 is to 1 as far as the masses are concerned, and the ratio of sulfur dioxide is 1 is to 2. So they are asking us if we have 16 grams of sulfur present. So if we have 16 grams of sulfur present, that is exactly half of 32. So in the molar ratio 1 is to 1, oxygen should also be 16, and in the molar ratio 1 is to 2, the SO2 should be 16 into 2 is 32 grams. So what have they asked? They have asked for the mass of oxygen. So mass of oxygen here is 16, making option C the correct option for this question. Question 14. Which compound has an empirical formula that is different from its molecular formula? Okay, so empirical formula is the simplest ratio of the atoms present in the molecule. So in A, butanol, we have just a single atom of oxygen. So in this case, the empirical formula would be equal to the molecular formula. In the case of H2O2, there are two hydrogen and two oxygen atoms. So its empirical formula would be HO. In the case of nitrogen dioxide, there is only one atom of nitrogen and two atoms of oxygen. So its empirical formula would be equal to its molecular formula. In the case of water, again, we have a single atom of oxygen present, making its empirical formula equal to its molecular formula. So out of these four given options, the only option that has the simplest ratio is hydrogen peroxide, making option B the correct option for this question. Question 15. 4 grams of sodium hydroxide is dissolved in 250 cm cube of water in a graduated flask. So the first thing is we calculate the moles of NaOH. Mass of NaOH given is 4. AR of sodium is 23. AR of oxygen is 16 and AR of hydrogen is 1. 23 plus 16 plus 1 gives us 40. So 4 upon 40 will give us 0.1 moles of NaOH. And this says that 0.1 moles of NaOH is dissolved in 250 cm cube of water. Okay, the next part. A 25 cm cube sample of this solution. So out of 250, we take out 25 cm cube of NaOH. So we need to calculate the number of moles that we have taken out. So this would be 25 divided by 250 into 0.1, giving us a value of 0.01 moles of NaOH that we have used. Now, what have we used this for? Let's continue reading the question. A 25 cm cube of this solution is titrated with 0.5 mole per dm cube HCl. Okay, so this is titrated with HCl. So the equation for the reaction of NaOH with HCl is NaOH plus HCl giving us NaCl plus H2O, in which the molar ratio is 1:1 for NaOH and for HCl. So what they have told us is that we have used 0.5 mole per dm cube HCl. Now, what is the question? Which volume of hydrochloric acid is required to exactly neutralize the alkali? Okay, so we need to find out the volume of HCl. We know moles of NaOH. So the number of moles of NaOH that are reacting would be equal to the number of moles of HCl that would react. Out of how much? Out of what they've given. What they have given us is 0.5 moles of HCl in a volume of 1000 cm cube, which is equal to a dm cube. Now, out of this, 0.01 moles would react because the molar ratio is 1:1 for NaOH and HCl. So 0.01 moles of HCl would react. So if 0.01 moles of HCl reacts, what volume of HCl would contain these many moles? This would be 0.01 divided by 0.5 into 100, and this would give us a value of 20 centimeter cube. This makes option B the correct option for this question. Question 16. Dilute aqueous solutions of potassium chloride and magnesium chloride are mixed together. A sample of the mixture is electrolyzed using inert electrodes. What are the possible products at each electrode? Okay, so we have potassium chloride and we have magnesium chloride, but both of them are dilute. So the cations are potassium and magnesium, both of them being more reactive than hydrogen. So this confirms that hydrogen would be liberated at the cathode. So at the cathode, oxygen no, potassium no, hydrogen yes, magnesium no. And the anion present is chlorine. So if this would have been a concentrated solution, then chlorine would have been liberated. But since they have mentioned that both solutions are dilute, so chlorine will be in a very small quantity in comparison to water. So the product at the anode would be oxygen here. So chlorine, no. Again chlorine, no. Oxygen, yes, and oxygen, yes. So the option with both the correct species that are produced at the anode and the cathode is option C, making option C the correct option for this question. Question 17. The table gives some statements about electrolysis and the reason why each statement is true. Which row shows a correct statement and the correct reason why the statement is true? Okay. So A. Aqueous copper 2 sulfate and aqueous copper 2 nitrate are suitable electrolytes when used to copper plate objects. Yes, both are soluble. And the reason is both solution contains Cu2 positive aqueous ions and can transfer copper from the anode to the cathode. Yes, both of these are correct, making option A the correct option for this question, but we will continue looking at the other options and seeing why they are wrong. Option B. During the extraction of aluminum from aluminum oxide, the carbon anodes have to be replaced regularly. Correct. Reason the anodes gradually dissolve in molten cryolite. No, no. The anodes are carbon brushes. Carbon reacts with the oxygen gas that is produced at the high temperature of the extraction, and this results in the formation of carbon dioxide. This is the reason why they need to be replaced. So the reason given is wrong. Option C, in the electrolysis of concentrated aqueous sodium chloride and of dilute sulfuric acid, the same products are formed. So it says concentrated aqueous sodium chloride. The same products are formed. In both cases, hydrogen is formed, yes, but in the case of concentrated aqueous sodium chloride, we will have Cl2 being produced, whereas in the case of sulfuric acid, we will have O2 being produced. So the products are different for each. And the reason that they've given here is H positive aqueous is present in both aqueous solutions. Yes, that's true. But in the case of sodium chloride, we have Cl2 present, and in the case of sulfuric acid, we have O2 being produced. And it said the same products are formed. No, the same products are not formed. Option D. When an aqueous mixture of zinc nitrate and copper 2 sulfate is electrolyzed, zinc is formed on the cathode. Okay. When an aqueous mixture of zinc nitrate and copper 2 sulfate is electrolyzed. So copper is less reactive than zinc. So zinc is more reactive than copper, yes, but that is the reason it is not formed on the cathode. Copper is formed on the cathode. Copper is produced because it is less reactive than zinc, and as well it is less reactive than hydrogen. So copper is produced at the cathode, not zinc. So this is the reason why all other options are incorrect, making option A the correct option for this question. Question 18. Students proposed 4 cells to produce electricity in a school lab. Which cells would produce the largest voltage in a safe way? Okay, so they have placed a copper and a zinc plate with copper sulfate solution. Okay, this would produce electricity. They have used copper and zinc with zinc sulfate solution. Okay, this should also produce some electricity. They have used sodium and copper. No, sodium is a big no-no. Sodium is a highly reactive metal. When placed in water, it is explosive. No, no. So option C is definitely wrong. It's not safe. And option D, they have used magnesium and copper electrodes with magnesium sulfate. So now this is the correct answer because magnesium and copper have a greater difference in reactivity as compared to zinc and copper. So zinc and copper would produce electricity, but the voltage would be lesser than the voltage produced by magnesium and the copper electrolytic cell, making the option D the correct option for this question. Question 19. Nitrogen oxides may form in the atmosphere during lightning activity. N2 plus O2 gives 2NO. Okay. The reaction is endothermic. Okay. Which energy profile diagram is correct for this reaction? Okay. First of all, option A is an exothermic profile. So that is wrong. Option D is an endothermic profile. Options B and C are both wrong because they do not have the maximum point of energy. Yeah, the hum that should be crossed in order for the reaction to occur. The reactants are directly being converted to products in option B in an exothermic process, and there is no hum. And in option C, the reactants are being converted in an endothermic process, but there is no hum or the transition state. So a being exothermic is wrong. B and C do not have the maximum point of energy during a reaction. And D is the only remaining option, making it the correct option for this question. But in D, you can see that the process is endothermic, and you can also see that there is a maximum energy level, which is called the transition state, which is present, which should be present during a chemical reaction. So, in with all aspects of an energy profile diagram, option D is the correct option for this question. Question 20. Which two processes are both endothermic? Okay. Combustion. Combustion is always endothermic. Cracking. Oh, I'm sorry. Combustion is exothermic. They are asking endothermic. Combustion is always exothermic. Combustion is never endothermic. Cracking is the one that is endothermic. So combustion is wrong, cracking is correct. In the next one, again they have used combustion. Combustion is wrong. Fermentation is also an exothermic process. So fermentation is also wrong. Cracking, as discussed before, is endothermic because cracking requires a high input of energy. We need temperatures of nearing 600 degrees Celsius. And photosynthesis. Photosynthesis also needs energy in order for the process to occur. So both are correct here. Option C is the correct option. Let's look at option D. Respiration. Respiration is an exothermic process and photosynthesis is an endothermic process. So one is correct and one is wrong, making option C the correct option for this question.